Alright, so this is a lesson on linear inequalities. In this lesson, at the end, we want you to be able to graph the line and shade the appropriate region. We want you to be able to determine what dotted lines and solid lines represent. We want you to be able to identify solutions to the inequality, and also we want you to be able to write an inequality from a given graph. Right. So we're going to start out by looking at this inequality where we have y is less than negative 2x plus 3. And I'm going to rewrite it as a y equals mx plus b equation. So this will be y equals negative 2x plus 3. So I'm going to graph that. There's my y-intercept of 3. Put a point at 3 on the y-axis. I'm going to use the slope of negative 2. So I go down 2, right 1, put a point, down 2, right 1, put a point. I could also go up 2, left 1, up 2, left 1. Okay. The next part is actually drawing in the lines. All right, I've got the points that the line should go through, so now I need the line. All right, and this is where we have to establish when it is solid and when it is dotted. If it's less than or greater than, it is going to be dotted because it's not equal to, so therefore we're going to have some blank spots. And so it's going to be a dotted line. If it was less than or equal to, greater than or equal to, it would be a solid line. It would look like that. And there are no holes in that particular line. All right, so everything that's on the line would be included in the solution. All right, so since it's less than, we're going to go ahead and draw in this line here. All right, and let's go ahead and extend this out. Okay. All right, so we've got the line drawn in. The next part that we need to look at is where do we shade in this particular inequality? All right, and we can look at the inequality until it's less than, so we want to shade below. That's one way of doing it. However, that does get tricky depending on which way the line is. So let's take a different look at it. And what we're going to do is we're going to choose what we call a test point. All right, and anytime we can choose the order pair 0, 0, it's going to make calculating the statement a little bit easier as far as whether it's true or false. So we just substitute in 0, 0. And we say, are those two sides, is it going to be a true statement? So is 0 less than, that would just be 0, so that would be 3. Is 0 less than 3? That is true. Since it's a true statement, we want to shade that region. Okay, so we will shade the region that contains the order pair 0, 0. Okay, so we would shade all this in here, and that would be our inequality being graphed. Right? A couple things that we can talk about from this point is possible solutions. Okay, everything in the shaded region is a possible solution. Okay. All right, and it doesn't necessarily have to be on a particular line. All right, real numbers that are in that area, and of course they're ordered pair solutions. All right, what is not a solution? So looking at this order pair, because it's on a dotted line, the order pair 0, 3 is not a solution because it's not equal to. All right, anything that is not in the shaded region, for instance, 5, the order pair 5, 3 is not a solution. Okay? All right, so those are not solutions. Okay. Let's take a look at the next example, and in the next example, what we're going to do is we're going to write the inequality from the given graph. All right. In order to write the inequality, I first need the equation of the line, or the inequality of the line. So I'm going to look and I'm going to say, okay, that's the y-intercept. The y-intercept is at negative 2. And I'm also going to need the slope, and it looks like it goes through right there. So I go up 3, go over 4. So my slope is 3/4. So my equation y equals mx plus b, that would be y equals 3/4 x plus, oh, sorry, not plus, but minus 2. Alright, so there's the equation, but again, we're supposed to be writing an inequality. So we need to establish, is it less than, greater than, less than or equal to, greater than or equal to. Since we're shading below the line, okay, it's going to be less than, and since it's dotted, it would not be equal to, it would stay just less than. So this inequality will be given by that equation. Alright, a few more examples. Alright, these are special cases here where we have y is less than, greater than, or x is less than, greater than, or equal to, that sort of thing. Alright, so the first thing we need to think about is what does the equation y equals 4 look like? So y equals 4 is horizontal, so we go up to 4. And the reason it would be solid is because it is less than or equal to. And because it's less than, we would shade that region below. Alright, the next special case is going to be x is greater than -3. So we look at x is equal to -3. And that's going to be a dotted line because it's greater than, but it's not equal to. We're going to go over to -3, and that line would be vertical, and it's greater than, so we're going to shade this way. All right, we want all those values that are greater than -3. All right, and the last thing I want you to think about for tomorrow is I want you to be ready to talk about this situation. Okay, so read through this situation. All right, think about what kind of questions you can ask and what questions I might ask you, and maybe if there's solutions to those particular questions that you could ask or that you think I might ask you. Make sure that you think about those, maybe jot those down and be ready to talk about it tomorrow. So there's your lesson on inequalities.